Today in this video we'll be covering linear equations, particularly how to solve one-step and multi-step linear equations. When solving linear equations, we have to keep in mind inverse operations. So when I say inverse operations, these are operations that are the opposites of each other. The first set of inverse operations are addition and subtraction. So whenever addition occurs, to cancel it out, you'll subtract instead by the same number. The second pair of inverse operations we'll be using are multiplication and division. We do these to cancel each other out. Whenever multiplication occurs and I need to cancel it out, I'll divide by the same number, and vice versa. One important thing that you do have to make sure that you do is that whenever you're doing one of these canceling ones, you have to perform the same operation to both sides of the equation. And you'll see these in our examples. For our first example, we'll be solving one-step equations. So one-step equations are equations that require only one step to solve. So for letter A, we have x minus 3 equals 5. So the main goal of solving linear equations is to isolate x, or whatever variable you're using. So to isolate x here, I want to look at whatever is on the side of the equation with x and work on canceling it out or moving it to the other side. So x minus 3 equals 5. First, we want to identify the operation that's being used. So that 3 I want to get rid of. And right now it's minus 3, so I know that's subtraction. What I'm going to do is do the opposite, which is addition. So I'm going to add 3 to both sides. Make sure, again, both sides is where you do it, the exact same operation. Now I'm going to simplify, so we have x equals 8. Now that I have x isolated, I know that x is equivalent to 8. Next we have letter B, which is x plus 6 equals 2. I want to isolate that x, so I'm going to identify what's with it. That 6 I want to get rid of. It's added to x, so what I'm going to do is the opposite, which is to subtract it. So here we have subtract 6 from each side. Simplify, x is equal to negative 4. For letter C, I have 1 over 3x is equal to 5. So when you have a fraction with a numerator of 1, that's the same as dividing it by 3. So I actually will write it a different way to make it a little bit more obvious. So this is the same as x over 3 equals 5. So numbers in denominators are really just showing it that it's going to be divided by that number. So of course that's division, and the opposite is multiplication. So what I'm going to do now is multiply by that same number. So we're going to multiply both sides by 3 in order to cancel out that denominator. Here I'll have x is equal to positive 15. And an important note is that if ever you're not sure about your answer, what you can do to check it is just to plug it back into the original equation and then evaluate to make sure that it's true. For example, if I plug in 15 for x, we have 1 over 3 times 15. 1/3 of 15 is 5, so that one's actually correct. For letter D, we have 4x equals negative 8. I know 4x is just 4 times x, so I'll now divide by 4. So negative 8 divided by 4 is negative 2. Again, if you want to check it, you could just plug it back in. 4 times negative 2 is equal to negative 8, and that's true. Next, we're going to go into solving multi-step equations. So when solving multi-step equations, what you want to think about first is collecting all terms with your variable, or shall I say all variable terms, on one side of the equation, and then collecting all the terms with just the numbers on the right side. If we're solving for x, anything with x, I'll move to the left side, and any free numbers I'll just put on the right. But of course, if you put them on the opposite sides, that's fine. So for the first example, 2x minus 10 equals 12. I want to move all the numbers onto the right side. So I'm going to add 10 to each side. Then I have 2x is equal to 22. Dividing by 2 will let me isolate that x. So we have x is equal to 11. So we're still working on isolating that variable by getting rid of things in its side of the equation. And I do that by working from the outside in. I kind of get rid of things that are farther away from the x first, and then lastly that coefficient. We'll go into another example here. We have 5x minus 10 is equal to 3x plus 12. So for this one, notice that we have x on both sides of the equation. What we want to do is collect the terms with x onto the one side of the equation. So I want to move them both to the left-hand side, and then collect all the numbers on the other side. So I want to move that 3x to the left side and the 10 to the right side. And I'll do this by adding and subtracting the terms. Okay, subtract 3x from both sides. And in the same step, I'll actually add 10 to each side too, to get rid of it on the left side. This cancels out. Then we just subtract it. 5x minus 3x is 2x. 12 plus 10 is 22. And finally, we can just solve for x by dividing each side by 2, which gives us x is equal to 11. And again, we always know we can substitute it back into the original in order to check it. And we say 11 is the solution. Whenever you hear the word solve in math, you're always isolating a variable, finding a solution. That is it for this video. I hope you learned something. Thank you and have a great day.